In this video, we present how collision avoidance is performed with the haptic interface hug. We are able to prevent contacts with the robot links, and also with moving objects in the environment in 1 kHz. Our collision avoidance system is generic and extensible to other mechanisms. Additionally, it supports arbitrarily complex geometries. Here is how it works. First, we need the kinematic chain of the mechanism, and additionally, the geometries of the links and the objects in the environment. In our example, object markers are optically tracked. Second, for each mechanism link we generate voxelized distance fields and point sampled representations. So we do it also for the environment objects. Point sampled objects are ordered in sphere trees for faster collision detection. During online manipulation, each link is artificially dilated by generating a security isosurface. If the points of an object go through the security surface, the penetration of those points in the distance field is computed. The point normals multiplied by the penetration value yield the collision avoidance force applied to the joint. If humans are generically modeled as mechanisms and properly tracked, our system can also prevent collisions with them. After having configured the generic mechanism with its kinematic chain and geometries, our system requires only the joint angles and information of the environment state. With that, link forces and the respective joint torques are provided every 1 millisecond.